So in 8.4, our focus is going to be the natural logarithms, and natural logarithms are related to that exponential function e. Okay, remember that we talked about that function y equals e to the x power. Okay, its full name is natural base exponential function. Okay, and remember that e is just this irrational number. Okay, that's our symbol. So you also have a special log that's the inverse of the exponential function, and that is called the natural logarithm. So a natural logarithm has a base of e. Now, if I told you it had a base of e, you're probably thinking, oh, it just looks like that, right? Well, it is that, except we have a special way to write the natural logarithm, and it's ln. Okay, so the log base e of x is written as the natural log of x. So the ln, that means the natural log. Okay, and I don't know why it's ln and not nl. That's just the way they did it. Okay, so natural log ln is what we're going to practice writing. Okay, now let's look at this graph here. Remember, when you have inverse functions, they're reflections over this line, y equals x. So anytime you have your exponential function, remember how we have a horizontal asymptote? And then whenever we have a log function, we have what type? This is what you guys graphed the other day, right? Your log functions have a vertical asymptote. Okay? So they're going to be reflections of each other. Okay? Alright, so the same rules of logs apply to the natural log. And we're going to look at this example here. So if you have the natural log of 6 equals x, that's the same thing as saying the natural log of base e of 6 equals x. And so you can rewrite it using our base answer exponent. Okay, it's e to the x equals 6. And that would be called exponential form. The other form we're going to put values in is log form. So if you have the log form, I always tell myself that it's equal to your exponent. So if you're writing this in log form, you have your base, which is e, and then it's equal to your exponent. So instead of log base e, we're going to write it with the natural log. And that is how we are going to start this, is writing in those forms. So the first thing we're going to do is we're going to take the exponential equations and write them as logs. So those are the ones where you want to think to yourself, okay, when I'm rewriting it as a log, it has to equal the exponent. So my exponent is 3x. I know that when I write my final answer, it's going to be equal to 3x. And then what's your base of your log? E. Okay, so it's log base e of 45 equals 3x. But we're going to do one more thing, and we're not going to leave it like this, because log base e is the same thing as, the natural log, ln, and so this is going to be your final answer. Okay, so based on what we did for A, I want you to try B. Oh. And then there is one thing we're going to watch out for. Okay, so I am perfectly fine if you just jump to the natural log. When you see e, you know it's going to be the natural log. Now remember, it's equal to the exponent, so we should have it equal to 5. this is where you have to be careful, okay? You cannot write it like this. This is not correct yet, okay? When you write it like this, the natural log is only applied to the x, but we have to apply the natural log to the x plus 1, which means this has to be in parentheses, okay? So if ever you have a binomial, that's when it has to go in parentheses. Okay, they are not the same thing if you don't use your parentheses. So this is your final answer. And I just rewrote it because I didn't like my parenthesis there. But that is your final answer. Okay? Okay, so now we're going to look at example 2 where we're writing these in exponential form. So in exponential form, that's where you can do your base, your answer, your exponent. And if it's ln, what's your base going to be? E. Okay, so it's e to the power of 2x is equal to 36. Okay, so based on that, can you guys write out your equation for part B? Okay, and then for B, you should have written out e to the x power equals 0.0002. You can put that other 0 in front. You just don't have to. You do not like to. Okay, so for example 3, we're going to write each expression as a single logarithm, and we're going to do this using our log properties. Okay, so we're going to use log properties. So I want you to think for a minute, what are those properties that we talked about? There are 3 of them, and I want you to write them down here. Alright, so you're going to use the power, the quotient, and the product rule to make these into a single log. That means, see how you have ln and ln? Right now there's 2 of them. There can only be 1. Okay? Now, another thing I'm going to remind you of, and if you were, I know they have the answers in the back of the book to check. Sometimes the book writes these out a little bit differently, but we're going to simplify using these rules because that's what you're going to see again next year in pre-calculus when you do something similar. So you never want to leave values. Never leave values in front of your log, in front of ln. That was dramatic. Can you crack that open just because more people are going to come in? Okay, so never leave values in front of ln, okay? Okay, so when you're writing each expression as a single logarithm, the first thing you're going to look for are these numbers in front. We are going to be using the power rule, but in reverse from what we're used to doing, okay? So before, when you were using your power rule, you might have like the log of x cubed, and you would write it in front like this. Now we're going the opposite direction, where you have it in front, and you have to write it as an exponent. So this 3 in front, that is your exponent. So we're going to write it as the natural log of 3 to the 3rd minus the natural log of 9. Okay, so what we used is we used the power property. So I'm going to write to the side what we use, so when you're looking back you can see that. And then if you can simplify, you can. The only time you wouldn't be able to simplify is if it was a variable. So what is 3 to the third? Okay. And do you guys know where we're heading with this? Because I need to make it into one log. So what other rule can I use? Yep. So the natural log of 27 over 9 is your quotient rule. So when you're doing your homework, you don't have to write out on the side what you used, unless I'm getting people not showing their work, and then maybe I should go back to some proofs. You guys probably missed those. Can you simplify 27 over 9? Yep. So if you can reduce that, reduce. If you can't, you'll leave it. Yeah, divide it. Yep. Okay, so see how now we only have one log? So that is your final answer. Okay? So based on what we did for A, I want you to do B. Put that away. So anything that's in front becomes an exponent. So this is an exponent, this is an exponent. So you have the natural log of x squared plus the natural log of 4 squared, which we know is 16. Now when you multiply these together, you had this times 16, right? Now the proper way to write that is the natural log of 16x squared. It is a monomial, so you can leave it like this. Usually if there are multiple terms, I do put the parentheses on, but you don't need it unless it is a binomial. Okay? So you use your power rule, okay? Then you use the product rule, and then you write it in the simplest form. Simplify. Great. And then did you guys start part C, or did the fractions scare you?
No, I did.
Okay, so we are doing this without a calculator. Okay? Yeah. Everything that we've done so far today is without a calculator. So don't do that. We're going to use some brain power on this. I'm going to help you guys with different rules. So when you have the number in front, that does become your exponent. So it's 1/3 to the 4th power minus natural log of 1/9 to the 6th power. Okay, so we're going to do as much of this as possible without a calculator, and we're going to get pretty far. Remember that when you have an exponent with a fraction, you apply it to the top and the bottom. But 1 to the 4th power is just what? 1. We know 3 to the 4th, that's 81, minus, now I told you we're going to do as much as we can without a calculator. I don't want to do 9 to the 6th without a calculator, so let's just keep it like that for now, okay? So we're just going to keep it as 1 over 9 to the 6th. Now remember when you have minus, that's going to be the quotient rule. So if you have fractions, when you learn to divide fractions, you have them set up like this. 1 over 81 divided by 1 over 9/6. Right? You have that division symbol so that you could do what? What's the rule with fractions? Okay, great. So it's the natural log of 1 over 81 times 9 to the 6th. Okay, so if you had to do this without a calculator, look at this 9 to the 6th power. What could I do with 81? Yep. So if this was 9 to the 2nd, you would end up with 9 to the 6th over 9 to the 2nd. And then what could you do with the exponents? Yep. So just be the natural log of 9 to the 4th. Okay, so being able to manipulate numbers like this is going to be really helpful when you start to take those standardized tests. So if I can get you thinking about things in different ways, you're okay back there? You're okay? then that's just going to be helpful and make you stronger mathematically. And then for 9 to the 4th, that is something that I would let you do in your calculator. So you would do 9 to the 4th power, which is going to be 6,561. Okay? If I gave you something like that on a no calculator portion of the test, it would be a smaller number, or I'd let you keep it like that. Okay? Okay. So, on the back, we're going to be solving with natural logs. When you are solving exponential equations, you use the inverse. What's the inverse of an exponential equation? Yes, and just logarithms in general. Okay, so we used logs to solve yesterday, and in particular, we used which log to solve? We used the common log, which was base 10. Okay, today we're going to solve equations that have the base of e. And today we learned that the inverse of that function is the natural log. So yesterday we were taking the log of both sides. Today we're going to take the natural log, which is ln of both sides. I do write my ln in cursive often, so I hope that doesn't confuse you too much. And when you are solving, one thing you always want to try to do is isolate the base before you apply the natural log. So if you're isolating the base and your base is e, what you're going to try to get by itself is e to the x power, or sometimes there might be something else in the exponent. So you're trying to get the e here by itself. Okay? You're also going to be solving equations that contain the natural log. So the inverse of when you're doing the natural log is writing them in exponential form. Okay, so you've already done this with your normal logs, right? You've had log bases. Today we're doing log base e of y to the x. How would I write this in exponential form? E to the x equals y, right? So if you have the natural log of y equals x, all you're going to do is rewrite it like this. This is exponential form, and that is what you have to do when you have your logs. Okay, you need to write it like that. We are also going to be writing out exact values, because you're going to have some questions on your no calculator section where you're going to have to write them out with logs, okay? So I put this note here so that you know if you don't show all your steps on your homework, you are not getting full credit for that. There are other ways to solve besides logs that we've learned, but in this chapter, I am testing your knowledge on can you solve with logs. Okay, so that's why I'm being really picky about that. When you're solving each equation, you are going to round to the nearest 10,000. I'm also going to, like I said, show you what your exact values are. And when you're solving, you're always going to be solving for your variable. Okay, so sometimes you'll be given e, sometimes you'll be given the natural log. You're going to have a mixture of both of those. So let's start with the ones with e. So to undo a base of e, that's when you're going to take your natural log. And I'm going to show you how I'm going to let you write this out. So you're going to take the natural log of both sides, okay? Something that we did yesterday is we always use the power rule to do this. We'd write out x times the natural log of e, okay, equals this. Do you guys know what the natural log of e is? Do you guys know what log base 2 of 2 is? 1. Log of 10 is? 1. Natural log of e is? 1. Why? The base is the same as whatever your log is on. Because this means log base e of e. If you're trying to solve that, e to what power is e? 1. Okay, so what is really happening here is that cancels out to make 1, and x times 1 is just what? X. So this is what I'm going to let you do. I'm just going to let you show that those undo each other. You can cross them out. And then the exponent goes down in front, so you can just drop that in front there. So again, we know the natural log of e is 1. X times 1 is going to be x, so you can just drop that down in front. If I asked you for an exact value, it would be this. If I asked you for a value to the nearest 10,000, then we would do this. Oh, so will you guys find the natural log button on your calculator? It should be, is yours below or above the log? Okay. I have to use my baby calculator today because I left my other one at home. Okay, so now we're going to round to the nearest 10,000, which is 4 decimal places. Okay, and then this will be our rounded answer. And then when you have your rounded answer, you often see it like this. Do you guys remember what the wavy symbols mean? Yeah, great. Okay, so that's an approximate rounded answer. And then the last value, is that going to round up or stay the same? Round it up. Okay, so this is your rounded value. Okay, so now we're going to go to B. And for B, you have more things on the same side as e to the x. Remember that we're trying to isolate that value. So when you're trying to isolate that, you are going to use algebra to get e to the x by itself. So the first thing we're going to do is we're going to subtract 3 from both sides. Then your second step is going to be to do what? Divide by 5. So these first 2 steps should go very quickly. Now, you can see that you have e to the x on this side, so maybe leave a little bit of space for yourself so that you can write the natural log without having to squeeze it in there. So again, those are going to undo each other, and you'll have x equals, this is your exact answer. Okay, and then will you guys find your rounded answer, please? And we'll check that together. And then you can start thinking about C. Okay, so when you are rounding to the nearest 10,000th, you always look at the 5th decimal place. And that will tell you whether it rounds up or stays the same. Okay, now when we are trying to solve and you have the natural log, that's when you have to write it in exponential form. So that should be your first step. Rewrite in exponential form. Okay, and can you guys do that for me? Okay, and let's see if you can write it as an exact value and as a rounded value. Correctly. So whenever you see natural log, you should automatically be thinking that your base is e. Now, when you are writing in exponential form, it's always equal to the exponent. So you should have written e to the 3rd equals x plus 2. Okay, and isn't that exactly what we did on the first page with these two? Base, answer, exponent, base, answer, exponent. Okay, so now we're using that and we're going to use it to solve equations. So if I'm getting x by itself, I have x plus 2, what do I do to both sides? Subtract 2. So your exact answer would be e to the third minus 2. So that's the exact one. I'm just going to put that. Okay, and then your rounded answer, you get to evaluate. So now we're going to do e to the power of 3. You have to close your parenthesis, or else you're going to get like 2.71, whatever your e is, right? Because then you'd be doing e to the power of 1. So you have to make sure you close it. Okay, and then minus 2. And then we're going to round to the nearest 10,000th. So the next number after is 3, so you can keep it there. How many of you feel like you could start the next one? I'm going to do that for rounded. So it looks like road.
I'm going to start with an E.
That'll be second. This one we got to start with something else. Does this look like anything else we've done today?
Let's start with the product rule.
Yeah. Before you can rewrite an exponential form, you can only have one log. Okay? So you have to make into a single log first. Give yourself some room for this one. So you have to make into a single log. Use properties. Make into a single log. Then you're going to write it in exponential form. Okay, so yep, you need to use your product rule. So if you are using your product rule, what two things are you going to multiply together? Yep, 3x times 2x. Now you have one log and you can simplify that and then rewrite it in exponential form. Okay, so 3 times 2 is 6, x times x is x squared, it equals 9. Now, Joey, tell me what you're going to write it as.
I have no idea.
Do not say that to me when you just told me, when we just started this problem, what did you say?
Oh, I'm going to start with an E.
Okay, so e to what power? E to what power?
2.
Okay, look. Okay, when you're writing it in exponential form, see how I have this here? Okay, so it's always going to equal the exponent. So when you're rewriting it, this is your base. So it's going to be e to the equals
6x squared.
Okay, and so when you're doing your homework, the first part of your homework is going to be rewriting it in this form. So you should get some more practice with that, and then you can solve.
Yeah.
Okay, so when you're solving for x, you're going to divide both sides by 6 to get the x by itself. Okay, and then are you guys fine if I put the x on this side? I like it better over here. Okay, so it's e to the 9th divided by 6. Now, when you do this, you got to take the square root, and when you're the one that takes the square root, remember, you have that plus or minus, but this is going to be special. Do you guys know why? So whenever you have a log, whether it's a natural log or not, you can't take the log of what? Negative or 0. Okay, so if I were to keep this negative answer here, that would make it an extraneous solution. So you can reject the negative answer because you can't take the log of a negative. Okay, so we reject that answer. Okay, so when you are writing it as the exact value, you don't have to simplify that part for the exact value. You can write it just like this. And then let's go ahead and approximate it in our calculator. Okay, so see if you can plug that in, please. So you have the square root of, and then it's e to the power of 9. Make sure you close that parenthesis, or else it would make everything the exponent of e. You don't want that. It's e to the 9th divided by 6. Make sure that you can get that. Okay, and then we're still rounding to the nearest 10,000. Okay, and that would be your rounded answer. Okay. Alright, the next thing we're going to do is we're going to apply something that we've used before, and we're going to solve with logs. So again, if you do not solve these with logs, and if you do not show your work, then I will... Oh, please. I will not give you credit. Okay, so what is the balance of Sarita's account after 3 years? So she's depositing $750 in an account that pays 2.7% annual interest, compounded continuously. Why did I highlight compounded continuously? What does that tell us? Yeah, so it tells us what equation we have. Do you guys remember the equation? Yeah. P equals, yeah, PE to the RT. Oh no, A equals PE to the RT. Got too excited.
Reload.
Reload. Okay, so we know that it's A equals PE to the RT. Okay, so and that's when it's compounded continuously. So when you're trying to find the balance for part A, okay, you're going to have to make sure you understand what the model is. A model is just another word for your equation. It's an equation that models the situation. Okay, so we're going to plug in our values. So 750 is what? Yep, which is the value of P. 2.7 is going to be the rate, and we're going to write it as a decimal. Okay, and then the model itself, that's all you need. So this is just the model. But part A is asking us to find the balance after 3 years. The balance is A, it's the amount. Okay, after 3 years means I'm going to be plugging in, yep, okay, so that is something that you're going to use your calculator for. 750e to the power of, and then I'm going to use this little the times asterisk, so you know that you're plugging that all in together. Now, when you are dealing with money, you always round to what decimal place? Hundreds, yep, because that's going to be your change. That's going to be the nearest cent. So 750e to the 0.027 times 3. Okay, so we have $813.28 when we round. Okay, so that 8 is going to push that up to a 28. Okay, so that's where you're going to plug it in. Now for B, it starts off by asking how long. If it's asking you how long it's going to take the balance to reach an amount, what are you trying to find for B? Yep, so you want to find t, okay, and then they give you how long until it reaches 2,000. So where am I gonna plug in the 2,000? Yep, good. So A is your valence. So this is where you have to solve with logs. Okay, so 2,000 equals 750 E 0.027 T. So this is where you use your model equation, you plug in 2,000, and now we have to solve. We've done this before. It's just like part B. Well, not just like it, but very similar. Okay, so the first thing we want to do is isolate E. So what do I have to move over? 750. So to move over 750, I just divide. Now when you're doing this, I don't want you to calculate the decimal yet. We're not going to do that until the end. Okay, you don't even have to reduce it if you don't want to. I naturally will reduce when they both end in 0 because you could divide them both by 10. And I just do that so I don't have to write out as much or type in as much. And now, do I have anything multiplied to the E or added or subtracted to it?
Nope.
Nope. So that means it's time for us to do what to both sides? Natural log. So anytime you are solving with E, okay, if you have E, then you're going to apply the natural log because that's the inverse, and those two operations are going to undo one another, and you're just going to be left with the exponent being brought down in front. I just want to be able to see part C. Okay, and then again, we're not doing this yet. We're going to save it until the end, the grand finale. And then your final step is just going to be to divide by 0.027. Okay, so again, if this was something that I asked for an exact value for, this is what you would write. And then I'm going to have you round this to the nearest tenth. I want you to round your answer to the nearest tenth. Okay, so you can put this all in at once, or you can do it in multiple steps. You have the natural log of 200 divided by 75, and then you take that and divide it by 0.027. So you should get 36.3, and then what is our unit? Nope, this isn't. Years, yep, so it's asking you how long. It told you above that the time is in years here, the 3 years, so this is going to be your final answer. Okay, now part C is going to have a similar solving process, but the difference here is it says, suppose she wants to have at least $1,000 in her account, okay, after 5 years. If the interest rate remains the same, what is the principal she should invest? If you're trying to find the principal, what variable are we solving for? Yep. So we have to find P. It says the interest rate is the same, and she wants to have at least 1,000 in her account. So the 1,000 is going to go in for what? A. So 1,000 is equal to P E. They said they kept her same rate, and what's going to be your value of T? 5. Good. Okay, so you have 5 years, so that's your time. This is your amount. Okay, so if you want to get P by itself, the only thing you have to do is divide by e to this power. You can keep it just like that until you're ready to put it in your calculator. Okay, so all you're doing is dividing both sides by e to the power of 0.027 times 5. Okay, because we know that this will cancel out and you'll be left with P. So that would be your exact value. And then we'll do 1,000 divided by e to the power of 0.027 times 5. Okay, so this is the principal. So if you're finding the principal, that's going to be money. So we're going to round to the nearest hundred. So it'll be $873.72.